All right, picking up where we left off with the January 2020 exam, the part twos. So for the part twos, partial credit is awarded. So show all work, show every step, labels, make sure you read the directions. If it says justify, show your math. If it says explain, use your words. And just, if it's a formula, write a formula. If it says to round, make sure you round. So many points can be lost if you just miss a tiny thing. So just be careful, read the directions. Here we jump in. 25 says for n and p greater than 0. That just means that n and p are positive. That's what greater than 0 means. Is the expression blah equivalent to blah blah? So what I have to do is simplify this to see, is it equal to this? Off we go. So I'm going to tackle this part first. Now, these two things are being multiplied, and this is a lot of exponent rules, like a lot. So before I can use my exponent rules, I have to simplify this radical by getting rid of the radical. Now, it is a square root, so there's an invisible 2 here. For now, I'm just going to bring this down. So it's p squared n to the 1 over 2, and that's all being raised to the 8th, times, when you simplify a radical to turn it into exponents, they're going to become fractional exponents, and you're going to use what we talked about in class, which is TIBO. Top number comes from the inside, bottom number comes from the outside. So this is going to be p raised to the something and n raised to the something, and that's a fraction line right there. So for TIBO, the inside number goes on top. So for p, the inside number is 5 over the outside number, which is 2. So it's p to the 5 over 2. Now I do that same thing now with the n. The inside number is 4, so it's going to be 4 over the outside number, which is still a 2. So now that I've simplified that, I am multiplying this by this. Now, I know that when I use my exponent rules, multiplication means I have to add my exponents. However, this isn't simplified fully yet. I have a power to a power rule here. This whole thing, it shows me because of the parentheses, is being raised to the 8th. That means that 8th power belongs to both of these terms. And when I have an exponent raised to another exponent, I have to multiply them. So this is p to the 16th and n to the 1/2 times 8, which is 4. And now all of that is being multiplied by what I have over here, which is p to the 5 over 2. And I'm going to simplify this to end of the 2 because 4 divided by 2 is just 2. Okay, so now when I'm multiplying, I'm going to multiply the p's together first. It's going to stay p, but I'm going to add my exponents together. So it's 16 plus 5 over 2, and that gets me 18.5. And I'm looking at what I'm trying to get it equal to. This is, oh, I got to simplify this too. Good times, good times. So I'm going to leave it as a decimal for now. If I had to turn it into a fraction, I would have. It's entirely up to you. If you did decide to turn it into a fraction, it would have been 37 over 2. Okay, so now I need to multiply that. Noops. Now I need to do my n's. There we go. I'm multiplying the n's together, and I have to add their exponents. This one's a little bit easier. I get n to the 4 plus 2, which is 6. So when I simplified this side completely, that's what I got, and I'm trying to see if that's equal to this. First, when I looked at it, I thought it was fully simplified, but I can tell looking at it now that it's not because there's a p here and a p here. That needs to be simplified. I also don't even know how I missed this before, but this is under a radical. To use your exponent rules, you can't have it as a radical, so I need to do TIBO again, but for this side. So the p to the 18th and n to the 6th is going to stay, and I'm simplifying this right now. Now they're all invisible numbers. This is a square root, and there's a 1 inside of the parenthesis, or inside of the radical there. So this will end up being p to the 1/2. Now when I multiply my p's together, just like I did over there, I have to add the exponents. 18 plus 1/2 is going to be 18.5. So I get p to the 18.5, and the n to the 6th comes down. So when it's asking, are they equivalent to each other, you are going to say yes. Now, we've talked about it in class. I'm going to reiterate it again. The word justify means you have to back up your yes with some math. I did. My math right here says I simplified this side and I got this. I simplified this side, I got this. They're equal to each other, aka yes. If it said explain, you would have to put words to what you did. So you'd have to say, I simplified the radical, then I added my exponents together when I multiplied, and blah, 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 blah. If it just says justify, your math is justification enough. All right, did I skip one? Nope, number 26. Show why x minus 3 is a factor of m of x equals blah, justify your answer. So once again, I need to show my work to back up my answer. This one's a little bit tricky because I know what a lot of people are going to try to do first. We're going to try to factor this. If I factor it and this is a factor, boom, I showed my work. Now, if you try to factor this, it's got 4 terms, so I would use grouping. I take out an x squared here, and there's really no GCF here other than a 1. So I'm going to take out the x squared. I'd be left with x minus 1. Here I take out a 1, and I'm left with negative 5x minus 3. Hopefully you're noticing, big red flag, those don't match. That means this one can't be factored by grouping. It's a really good try to start with, but it didn't work. So now we got to try something else. So something else that we know from the long division rational functions chapter is that x minus 3 can be a factor if you use the remainder theorem. And if I divide this whole thing by x minus 3 and get a remainder of 0, that means it is a factor. So that's the way that I'm going to use to tackle this. I wouldn't blame you at all if you tried to factor it first, but when that doesn't work, you've got to tackle it a different way. If you end up doing the remainder theorem and you get 0 as your remainder, that means that this is a factor. So that's what we're going to use. Now the remainder theorem tells me that if I'm dividing by this, I have to plug in x equals positive 3. If I was dividing by x plus 3, I would have plugged in a negative 3. It's just the opposite sign. So I have to plug in 3 to m of x. So I'm going to do m of 3 equals. Now everywhere I see an x, boop, 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 I'm going to plug in a 3. So this is 3 to the third minus 3 squared minus 5 times 3 minus 3. Now when I plug that in, I get 0. If you get 0 as your remainder by doing the remainder theorem, that means that x minus 3 evenly goes in to this. And if it evenly goes into it, that means that yes, it is a factor. Notice how my answer is specific. I didn't just say yes. I said yes, not it is a factor. X minus 3 is a factor, not just is a factor. I said what it is a factor of. Use details in your answer. Be as specific as you possibly can. All right, 27, describe the transformation applied to the graph of p of x equals 2 to the x that forms the new function blah. So it started at 2 to the x and it became this. So hopefully you're noticing there's 2 new numbers. One of them is the minus 3 up here. The other one is the plus 4 on like the outside of that part. So I need you guys to really, really think about this. Transformations are going to be either shifts, stretches, compressions, reflections, that kind of stuff. So the 2 to the x is the part that I'm focused on because that was the OG function up here. 2 to the x is that. The only 2 things that happened to it were the minus 3 and the plus 4. So there are no reflections here because there's no negatives. When you're adding and subtracting, those are shifts. So this is going to be a shift and this is going to be a shift. Now I need to figure out which direction these are shifting. Ooh. So look at where the minus 3 is. I'm going to get rid of all my boxes now. That minus 3 is up there with the x. If it's changing or affecting or happening to the x, that means it's a horizontal shift, which means it's either left or right. Now what you need to remember about horizontal shifts is it's always the opposite. So when I see a minus 3, my brain's like, oh yeah, that's left, but horizontal is always the opposite, so this one's going to be right 3. Now the plus 4 is not directly happening to the x, it's happening to the whole function, which means it's a vertical change. It's changing the y. So it's either up or down, and vertical shifts are true to what you see. So when I see a plus 4, I know that that's going to be up 4. Perfect. Now, here's something else that we can do. Because these don't have any like p of x or f of x or anything inside of the function, what I could have done is graphed each of them and then just see how it changes. So work smarter, not harder. So if you forgot the hairy monkeys thing and the horizontal changes happens to x, blah, 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 I would graph that in my y1 and then graph this. Oops, I lost it. 2 to the x. Oh, gosh. Ah! Sorry. I wonder how, there we go. Oh, my. I didn't know it could do that. That was fun. 2 to the x minus 3. So Hello, my 84 people. When you type, it goes up there and you type the whole thing up there. Kind of makes sense. My 83 people. If you have more than one thing in the exponent, like an x and a -3, you have to plug in your exponent with parentheses around it. Sorry, I jumped pages here. So this is 2 to the x -3. My 83 people, type in 2 to the parentheses, x -3, close your parentheses. You are telling your calculator that whole thing is an exponent. 83 calculators have to do that. 84s go right up to the top and type it in. If you have an 83, you have to put it in parentheses. Otherwise, it won't put that -3 up there. And then when I get out of the exponent, I'm going to type in the +4. Now, when I graph these, my original one, my original one is blue. My new one is red. So I have to look at what happened to get from blue to red. It looks like it went right and up, and that's exactly what happened. Right 3, up 4. Boom. Yeah, that's not super helpful. So there we go. Right 3, up 4, bam. You can't always do it the graphing way, so make sure you memorize your hairy monkey rules. Sometimes it'll be like f of x plus 3 minus 7, and you need to know that this is left 3, down 7. You can't type in f of x into your calculator. All right, number 28. We love these questions so much. I know I do. The parabola, blah, has its focus at 3, 1. Determine and state the equation of the directrix. Now, a reminder, every parabola has a vertex. If the focus is above it, the directrix is equidistant below it. If the directrix is up here, the focus is equidistant beneath it. So what I mean by that is if these are 2 away, these are 2 away. If these are 1 away, this is 1 away. They're equidistant from each other no matter what side. The vertex is always going to be in the middle though. So what I need to do to come up with the equation of the directrix is plot the focus and find the vertex of this equation. So I'm going to find the vertex the fast way, and then I will also show you another way to do it. The vertex comes from transformations. An original parabola has a vertex at 0, 0. Then this one shifted right 3 and up 6. If I move 0, 0, right 3, it's going to be at an x value of 3, and then up 6 will have a y value of 6. That means my vertex is 3, 6. What if I don't remember that rule and I completely space out on the exam? Type it in your calculator. This is -1 divided by 20, parentheses, x minus 3 squared plus 6. And then I go to my table, and I'm trying to find that middle value. I already know it's at 3, 6, so I can kind of pinpoint in on it. But if you look right here, the 3, 6 is right in the middle because there's the 5.95, the 5.8, the 5.55. Everything is surrounding it with that pattern. So that means 3, 6 has to be the one in the middle. So there's 2 ways to find the vertex. Use your calculator or use your hairy monkeys. Okay, so the vertex is at 3, 6. It says the use of the grid below is optional. But guys, we've always done these by graphing, and having an actual grid will be so significantly helpful. So I'm just going to plot my axes real quick so I have a reference point of where to go off of. There's my axes. Just a reminder, when you guys are doing graphs on the exam, you can absolutely use pencil, but all of this needs to be in pen. Okay, so I'm going to plot 3, 6. It's right here. That's my vertex. The focus is 3, 1. So I go right 3, up 1. This is the focus. Now, if it's got the focus beneath it, it's going to be more like this situation. And I've already plotted the focus. I've already plotted the vertex. Now I need to find the directrix. So to do that, I have to find out how far apart these are from each other. 1, 2, 3, 4, 5. That means the directrix is 5 units up. 1, 2, 3, 4, 5 is going to be right here. This is 5 units up. Okay, my axes weren't in the best spot, but it's okay. I still use the grid to help me. If I went up 5 more from the vertex, which was at 3, 6, plus another 5, I'd end up at the line y equals 11. So my answer is y equals 11. Not so bad, not so bad. I hope. All right, next one, 29. Given the geometric series blah, write a geometric series formula, S of n, for the sum of the first n terms. Then it also has like a part B sort of. Use the formula to find the sum of the first 10 terms to the nearest 10th. So right away I see the words geometric series. What that tells me to do is go to my reference sheet and find my geometric series formula. Because I remember that one's on the reference sheet. Why can't I find my reference sheet? There we go. So I go to the back, geometric series is this one right here. So to show all of my work, I am going to copy that formula down on the question, and then I'm going to use it to plug into. So back up, back up, back up. Here we go, geometric series, which is Sn equals a1 minus a1 r to the n all over 1 minus r. Now we also need to know what everything stands for and how to plug everything into it. So a1 is the first term. Since it gave me my sequence, I can see that the first term is 300. And r, because this is geometric, is my multiplying pattern. So what I'm multiplying each of these by to get from one number to the next. So remember, it's a little hard to figure out what I'm multiplying 300 by to get to 360. So what I can do instead is take the second and divide by the first. So 360 divided by 300 gets me 1.2. So that means my r is 1.2. And you can double check that it works. 360 times 1.2 does get me the next number, which is 432, and so on. So that means I'm multiplying by 1.2 each time. Now here's the tricky part about this question. It is saying right here to write the geometric series formula S of n for the sum of the first n terms. So at first, the first part of this question tells me to not plug anything in for n. So here we go. S of n equals a1 is 300 minus 300 times r, which is 1.2, to the n, leave n alone, over 1 minus r, which is 1.2. This is the first part of this question. Use the formula to find the sum of the first 10 terms. N is the number of terms. So now I plug in 10 for n, and then I evaluate that in my calculator. So this will be S of 10 equals 300 minus 300 times 1.2 to the 10 over 1 minus 1.2. And then usually people ask me, what if I just went straight to this? Wrong. It told you to write a formula first, so you have to write the formula first. So now, when you're plugging into your calculator, you have to plug in the top first, press enter, then you have to divide by one number. So I'm going to simplify that first. 1 minus 1.2 is negative 0.2, so this gets replaced with just that one number. Now I'm going to plug in the top, 300 minus 300 times 1.2 to the 10th. Boom, I get negative 157.52092672 over negative 0.2. Do I have to show that step? Why not? Show all of your steps. The more work, the merrier. Divided by negative 0.2 will get me my final answer, 7787.6046336. So I go back up to the directions, and it tells me to round to the nearest tenth. What if I didn't read that and I didn't round? Guys, this is only a 2-point question. If you don't round it right, you lose a full point, so be careful. The nearest tenth is this digit. 0 does not bump that up, so it's 7787.6. I shouldn't have a decimal there. Boom. 7787.6 is my answer. All right, moving right along. The next one looks terrible. Here we go. It says visible light can be represented by sinusoidal waves. Remember, that just means sine, cosine waves, like trig functions. 3 visible light waves are shown in the graph below. The midline of each wave is labeled L. Based on the graph, which light wave had the longest period? Justify your answer. If we don't know what period means, this question is going to be very difficult. The period is the length of one curve. We talked about it in class. It's like the end of a curve, kind of like a period is the end of a sentence. So if it helps you to remember it that way, the end of one curve is the period, like the end of a sentence. So based on the graph, which light wave has the longest period? You have to find which one has the longest length for one full curve. So we need to kind of trace out one full curve for each of these. It's kind of hard to see. I think I'm going to color code these. So A is that gray looking line. So one full curve of the gray would start right here. It would go down and then comes back up. That is one full curve for A. B, if I trace one full curve, we'll do it from up here. It goes like this, one full curve, boom, just like that. And then green is that last one, the solid black line. Oh, well, that's kind of fun. So if I start one full curve, it's going to be here. I go up, and then I go all the way back down, and I realize it goes even further out to there. So if you're looking at the length of all three of these curves, you can kind of tell right away. I was able to trace a full red one. I was able to trace a full blue one. I was not able to trace a full green one. So the green one's going to be the biggest, which means C has the largest period because it has the longest curve. So to justify our answer, you can't just say, oh, well, I looked at the graph and it looks longer. We're going to have to do some math here, or you could say it goes from... So justify when I say you need to use your math to like literally justify your answer and prove your answer. You can use words also for justify. So I'm going to use words for this one, and I'm going to say C is longest because it starts at about, what would be right there, 60, and goes further than 600. Now I can actually find the length for B. Let me keep these color coded. I can actually find the length for B because I know the full beginning and I almost know the full end point. The end point's about right here. And each of these are going up by 20, so that means this is ending at about 620, and this one is starting at 160. So for B, it's 620 minus 160. So I do 620 minus 160, and that one's length, horizontal length I should say, was 460. And then for the graph A, the largest was right at 600, and it started at 60. So 600 minus 60 is the length of this one, which would get me 540. So justifiably, if this one's period or horizontal length is 460, this one is 540, but C went from 60 to more than 600. It has to be higher. We don't even know where it ends, right? It's somewhere over here, but it's going to be higher than 540 because the distance between 660 is 540. And I know that it goes past 600, so this one has to be the largest because it's bigger than the other one. Bam. Oh, that's so colorful and pretty. Love it. All right, number 31. I also want to remind you guys that they give you a lot of space on the exam. This is a full page question. Don't panic. Sometimes you'll use the space, sometimes you don't really need it. Like for some of these ones, I wrote really big. We probably didn't need that much space, but you can use the whole page. That's the whole idea, is they want you to have more than enough space. Okay, so 31. Biologists are studying a new bacterium. They create a culture with 100 of the bacteria and anticipate that that number of bacteria will double every 30 hours. Write an equation for the number of bacteria B in terms of the number of hours T since the experiment began. Another quick reminder, if it tells you to use letters, you have to use those letters. So this is the function B in terms of T. So it's going to be B of T to start. You have to use the letters they give you. If you have an f of x on here, minus a point. And these are only 2-point questions. Okay, so there is no like keywords that tell me a formula to use for this. You just have to put the information in terms of a formula. So something that I do remember is that if something is doubling, it's going to be an exponential function, which is in this format, y equals a times b to the x, where a is where you start, and b was what we called the multiplier, what you multiply by each time. So if a is what I'm starting at, and it says that it creates a culture with 100, 100 is going to be the initial or starting amount, times, what's the multiplying pattern for this one if I'm multiplying by, or if I'm doubling, I should say. If you're doubling, you're multiplying by 2. Now here's the trick for this one. It's doubling every 30 hours. So it's not going to double like typically we would just raise this to the t. That's not going to work because if I plug in, let's say 1 hour, it can't just be raised to the 1 because it only doubles every 30 hours. So that's not going to work. I need to adjust something about my exponent to make it happen every 30 hours. That's something that I'm going to have to do is put it over 30. Now typically people are either between multiplying by 30 or dividing by 30. Here's what you have to think of. Literally, plug in any random example. Let's say I want to find out the amount after 60 hours. If I do 30 times 60, 30 times 60 is 100, no, too big, way too big. It is not going to get you the right answer. That'd be the amount of, the amount of times that it's doubling, and that's not correct. If it doubles every 30 hours and I plug it into this, 60 divided by 30 would be 2, and that means it doubled twice, because if it doubles every 30 hours and it's going for 60 hours, that would have been 2 times that it doubles. So just kind of use a sample problem that makes sense. I use 60 because 60 divides by 30 nicely. It could have done 90. Okay, don't use something like 2, that wouldn't divide nicely. But this will end up being my answer. And what I mean by like check your answer is just plug in random numbers and make sense of the problem. It should end up working out for you. And again, make sure you have B of t on there as well. All right, number 32. I loved that they put this example on the exam. It is such an easy one, guys. It's just graph. Graph y equals x to the third minus 4x squared plus 2x plus 7. Perfect. Calculator. If I'm graphing something, I go to my y equals and I type it in. So be careful typing this in. If you type this in wrong, you'd be very disappointed. It is x to the third minus 4x squared. Oh, okay. Minus 4x squared plus 2x plus 7. Now you can hit graph to see what it's supposed to look like first. But ultimately what I want is my table. Now, this grid is going out by probably 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 10 in each direction. So I can't plot anything bigger than a 10. I'm just going to pick all of the possible points. Guys, try to not go bare minimum. Okay, all the possible points that'll fit. -1, 0. 0, 7. Notice I didn't go to -2 because that has a y value of -21. That won't fit. So -1, 0, 0, 7. My next point is 1, 6. Then 2, 3. Then 3, 4. And that's it. That's all that's going to fit because the next point is 4, 15. And 15 is too big. So now I plot these. -1, 0 is here. 0, 7. 1, 2, 3, 4, 5, 6, 7 is here. 1, 6. 2, 3. And 3, 4. And then I look at that and I'm like, what is happening here? That is a very ugly graph. So I go back to this and I look at what it's supposed to look like. And I realize it is supposed to go up and then back down. So probably like this, but that's kind of ugly. So what you guys need is the turning points. You don't know that this and this are the turning points. You have to actually figure out what the turning points are. And I can do that on my calculator by pressing second trace. Now, back to the graph real quick. There's a maximum up here somewhere and a minimum here. It doesn't matter which one you find first. I'm going to do the maximum first by doing second trace and going to maximum. Now remember, it walks you through what it wants you to do. So I need to do left bound first. So see my cursor. I know it's a lot smaller than yours, but I'm moving it to a little bit to the left of the maximum. Press enter. Right bound means move a little bit to the right of the maximum and press enter. And then you guys have to press enter one more time. Mine already did it. But my maximum is the point about 0.3 and 7.3. I'm only rounding those because I'm plotting it and I'm doing as close of an estimation as I can. So 0.3 up 7.3 is a little bit higher than that other point. It's going to be about right here. So I need that point on my graph to see where it goes to its highest. Now I need to do the same thing with the minimum. It's somewhere down here. So I'm going to do second trace, go to minimum, and once again it walks me through what it needs. I go left bound, so a little bit to the left of the minimum, press enter. Right bound means move your cursor a little bit to the right of the minimum, press enter, and then you guys press enter one more time. And I get that when I round my minimum, it's about 2.4, and the y value is about 2.6. So I'm going to plot that point, 2.4. 2.4, 2.6, it's about right here. Now that I have all of my nice points, I can connect everything. So this goes all the way up like this and turns at that maximum, comes down like this, turns at the minimum, and then comes back up. And there's my graph. Boom. Not so bad, not so bad. All right, I'm going to stop there and pick up on this part 3 in the next video. If you have any